everyone, George here, and we are back again working in my implementation of Five Nights at Freddy's. If you remember from the last video, we were working with the puzzle of assembling an animatronic yourself, and we went through and we basically took apart all the different pieces of it so that we could lay them out throughout the room and then have the player have to assemble it slowly from the ground up. Now, I already thought about, in the last couple minutes between the last video, a little mistake I made, so I want to jump over to Maya really fast and just change one thing. And that actually is where the feet are going to connect. Right now I have them at a central point in the world. I'm going to go ahead and add another locator and put this right below here. And I'm going to put that at the 0 point in the Y direction. And I want a location where I'm going to be able to put a collider for this foot to go. I'm going to do the same thing again. I'm going to bring this, actually, let me delete that one. Let me grab this one, duplicate it, move it down, and then set that Y to 0. And let's change the names. So we're going to need our foot connection point. And what do we call this before? Our foot connection point. Let's call this base, I guess. Base connection point. And then our base connection point. And do a real quick export of this out. Foxy, file, send to Unity, selection, and assembly. Whoops. Assembly model, save, export, go back to Unity. Come back up here. I'm going to delete this just in case something went wrong, and we will bring back the assembled model right there. And now, let's see, what is this? That's not what I want. Let's get rid of that. Now, rather than work in this scene, which has a lot of stuff going on, I think I'm going to create a new scene just for this assembly stuff. So let's go to File, New Scene, Save, and open that up. File, Save, Scene As. We're going to go back to Scenes. We'll do Test, Assemble, Animatronic. Okay, now let's go ahead and grab our assembly model, bring it in here, frame on up, and take a look at what we're going to deal with. Okay, so obviously we're going to need some scripts to make this work. Let's create a new folder, create a folder and just call this assembly. And we're probably going to have an assembly manager. So let's go ahead and make that. Double click it, open it up in Visual Studio. Okay, let's close out of everything else. So close all, let's see, close all but this. Keep that one open. Okay, and you too. Make that a little bit smaller. And I'm going to move this off for now. So thinking about how this is going to work, I'm going to need, the player is going to pick up one of these objects with their VR controller and then move it around, and they're going to have to place it in the correct location. And those locations are going to be where the locators were at. So let's come over here really fast, and wherever there's a connection point, let's just change that tag to something that it's going to be a little easier for us to work with here. So there we go, just so that I can see what I'm doing. All right, great. Now we have all of our different points clearly labeled for us to work with. And let's go ahead and start making some scripts to work with. So I'm going to have to, on each of these points, have some sort of a collider. And when you click on it with the correct thing selected, there we go. Let's, I don't know how I move them all together in the same, okay, that's cool. I didn't know I could do that. Let's grab everything and start moving them together to make my life a little bit easier. Great, and there we are. And now all the connection points, almost all the connection points. Let's grab these last bits. Bring them down here. So now all the connection points are together. But more importantly, I'm going to have all of these have some sort of a collider on them. Wow, way too big. And actually, what's the scale of our model? Because this should... actually, these things have crazy scales, don't they? Because of everything that I had to do. Yes, they do. All right, so let's fix that really fast. I'm going to come back over here, get rid of those sphere colliders. Come back over to Maya and grab all of the connection points. Go to Modify, Freeze Transforms, and hit Apply for Rotate and Scale. And that should do it for me. Save it again, File, Export, or send to Unity, Selection, and Assembly Model. Now coming back over here, let's take a look at what my scale, all my values are now 1, so I can come back and at least, okay, they're still huge. What is up with Foxy's scale? Oh, the Foxy scale is 12 in this thing. That's the problem. Okay, so let's fix that really fast. I believe we fixed this in a different version, but because I am using an earlier Foxy that had all the separate pieces, it's kind of fallen apart. So let's go to Foxy, modify, freeze transform. I'm just going to have scale selected, hit apply, and let's see here. Are all these, now all of these pieces got scaled way down, and I don't like that, so I am going to scale each one up again, and now I'm going to freeze their transforms individually. Hit that again. Oh, really? I can't. Ah, I guess you can't. Okay, never mind. You can't do that. So we're just going to export it out as it is. File, send to Unity selection. Okay. Now hopefully this is going to work a little bit better for us. We don't have crazy stuff going on. Much better. Now they do have to be a lot smaller. So let's make that maybe 0.1. So that's where you have to click and drag the thing to make it work. And maybe even 0.075. There we are. So you got to get it really close to where it needs to be. Okay, so we're going to have a script attached to each one of these that's going to detect when you've actually moved over that area. So let's go ahead and create that script and go to Assembly, right-click, Create C# script, and let's call this Snap Point. I guess is a good thing, or maybe Assembly Snap Point would be better, huh? Just in case I use snap points for something else in the future. Okay, let's open that up. And I'm trying to think about this in a way that's going to make this robust. I don't want to just hard code everything, because if I do that, this animatronic is obviously not the last one I'm going to be using, and it might change dramatically how this whole system works. I kind of want something that's going to be a little bit more modular. So assembly snap point, the most important thing here is we need an on trigger enter. And we're going to need to see whether or not it's the right part. So each of the snap parts are going to need to have a game object, correct part. They need to know what part they're assigned to. So game object, let's make this serializable. Serialized field, excuse me. On trigger enter, we're going to check to see if other dot name dot is equal or equals. Or actually, no, we're going to do other dot game object is equal to correct part. And if that's true, then we can snap that part to the position. So we're going to want to take other dot game object dot transform dot set position. Nope. Or dot position, excuse me, is going to be equal to this snap point's location in world space. So this is going to be this dot transform dot position. So that should hopefully work. Visibility order failed. 6 does not equal 5. Unity Engine GUI. That is not my fault. So I'm going to ignore that right now. Let's go ahead and grab the assembly snap points to each of these. And we're going to need to assign each one of them the proper snap point up there. So of course for the feet, we're going to need snap points. So let's come on down here. So we've got, now I almost wish I hadn't separated these things. Tail connection point, therefore we need the tail, right? Yeah, tail. We have chest innards connection point. So then we need the chest innards. And I want to fast forward while I set this up so you don't have to watch. Okay, with that, we have all of the parts actually put in the right places, so that works just fine for us. Now I'm trying to think how I want to test this. I don't kind of want to jump into VR just because I have to set everything up. I should just be able to drag it over, and once it hits the right thing, it should happen. I am going to need colliders on all the different objects, so let's go in here and do that. And they need to have rigid bodies on them as well. So let's get rid of the connection points. Let's grab all of these, add component, rigid body. Since they're going to move around, we're going to do collider, and I guess we're going to do box colliders for everything. Yeah, that seems to work pretty well. And I guess we can start separating the pieces and kind of see what happens, huh? So these aren't zeroed out in any way, so I can't just bring them back to the right position. So doing this is kind of going to make a mess. Let's add that manager into the scene really quick. So create empty, not there though. And let's do assembly manager. And what the assembly manager is going to eventually handle is actually determining the order of things and how we should progress. Because some things, for instance, such as the quads right here, or hamstrings, or whatever you want to call them, require that two things be put in place before the hip can actually be inserted. Therefore, I'm going to need something outside of these two to manage this entire system. So coming over here, I should probably have a list, maybe, or an array. Let's do game object. Let's see, should it be an array or should it be, I forget, do lists show up in Unity as something that's serializable? So let's just do a list of, I want to do a list of int arrays and call this groups, or not groups, but assembly levels. Let's do that. Let's make that serializable. Serialized field, excuse me. That over there, take a look at assembly manager, and no, lists are not something that will come along for the ride, are they? All right, so I'm going to create another class here. We're going to do something interesting. Let's go to create C# script, and let's call this assembly level. An assembly level is going to be a grouping of objects that need to be put together in order for the next level to start working. And in our assembly manager, we are going to have an array of assembly levels. Which will get created in the inspector. Okay. And our assembly levels are going to have lists themselves, or arrays themselves. We're going to do game object array required. Should they be game objects or should they be, I guess, assemblies? No, they should be game objects. Required for level completion. Let's do that and make that also a serialized field. I hope this works. We're going to find out. Now, coming over to the assembly manager, I'm going to do size. I'm going to say, let's just do how many levels? So there's 1, 2, well, actually no, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 possible levels, maybe. I'm not exactly sure. So we got to make this serializable. So system.serializable. And let's see if that works for us. So coming over here now, let's make this 1. And, oh, it does not go deeper into the hierarchy, does it? That kind of sucks. I'm guessing I would need to create my own inspector editor type thing to make this actually work, to where I could drill down into each level and drag components in there, which would be kind of interesting, but it's not something I'm going to do tonight and work on. So under Assembly Manager, what I am going to do, though, is create empty game objects that are going to be each assembly level. Assembly level 1. Let's see, and let's duplicate this a couple times. And I hate how it does that, the naming convention in Unity. And add assembly levels to each one. Let's see if we can get at least part of this working. So required for level completion. What game object is required? So assembly level. So do I require that the feet go down first and then these parts and these parts, or can I let the player build up one side all the way? I'm thinking I'm going to have to do that. Let them build up each side and then make an assembly level that requires all of the stuff. So left leg, and then right leg. Or left foot, excuse me. Left foot, right foot. And then left shin, right shin. This is probably going to all fall apart. Okay, let's start with that. So each one of these only has 1 in it. So let's put in 1. So left foot coming around over here. Let's open this up and left foot, left shin, right shin. There we go. Okay, so these levels only get completed when that happens. So we got to do a test to make sure that actually occurs. So inside of assembly level, we need to, and actually, I don't think I need this to be serializable anymore, but you know, whatever. Actually, yeah, I don't. So let's just get rid of it. So I need to know when I have this actually occur. I need to know what assembly level this unlocks upon completion. So let's do a couple things here. Let's do a bool completed is equal to false, and bool unlocked assembly level, or levels really. Trying to think, because some of them will unlock more than one level. So I need to do assembly level array unlocked assembly levels. And that's going to be done as a serializable field, or serialize field. There we go. Okay, getting somewhere now. We can come up here to left foot, and now it has unlock assembly levels. It unlocks one level, and the level it's going to unlock is left shin. And right foot has one unlock level, and that's going to unlock right shin. Save, great. Now this still needs to be queued that it's unlocked. So let's see. So we have completed, but we should probably also have, do we need an unlocked? Bool unlocked. And let's make a method. Public void unlock assembly level. Okay, and that's just going to say unlock is equal to true, and that's it, I think. So coming back to the assembly manager, the first thing the assembly manager is going to do is it knows I don't know if it needs to know every assembly level. I think it might only need to know the starting assembly levels. Starting assembly levels. And in start, it's going to iterate over all starting assembly levels. So int I is equal to 0, I is less than the length, starting assembly levels dot length, I++, and then we are going to just say that starting assembly levels I dot is, what did I call that stupid thing again? Unlock assembly level dot unlock assembly level. Okay, so those become unlocked at that point to start everything off. Now the assembly snap points are going to be the ones that need to inform the assembly levels. Now the question is, the assembly snap points though, there are multiple ones assigned. Assembly levels can have multiple snap points inside of them that are working. Therefore, I can't put these on the same game object. They do need to be distinct. So I can't just unify this into one class. So on trigger enter, what I need to do is collider.other. This snap point needs to have a coincide assembly level that it is a part of. Now right now I'm storing the game objects. I think I also need this thing to store the associated assembly level. So let's do serialize field assembly level, associated assembly level. I know that's a long one, but whatever, sue me. And when this occurs, I'm going to want to call associated assembly level dot, actually that's a good point. What do I want to call? I'm going to need a different method actually. You can unlock an assembly level, but you also need to instruct it. Public void assembly snap occurred. There's got to be an easier way to do this. I'm just not thinking about it. I'm going to pass in, I guess, the assembly snap point, and I'm going to call it ASP. And I need to see whether or not this is one of the assembly points that we have. We are going to actually, so right now we actually don't, required for level completing, we're storing game objects. We shouldn't store game objects. We should store assembly snap points, shouldn't we? No, I shouldn't store assembly snap points. That is not what I want. I do want game object. assembly snap occurred, game object, or geo, let's just call it geo. Okay, that gets passed in, so assembly, associated assembly level dot assembly snap occurred, and I'm going to pass in other dot game object, because that's the object that has been snapped. This is now going to need to iterate over all of the game objects that are required to find out whether or not that is correct. So for int I is equal to 0, I is less than required for level completion dot length I plus plus, and we're going to do required for level completion I equal to game object, and we need to do an if. So now we need to have some intelligent logic here that knows what's going on. So right now we've identified that yes, this game object is one of the ones that we require for this level. I also need to know though if all of these game objects have been snapped properly. So really we need another class that piggybacks on each component that is an assembly piece is what it should be called. So let's make that class as well. I know this seems like I'm adding all this crap and it's like, why am I doing this? But I'm doing it because by making it this way, I have not hard coded everything, and I can literally create any kind of animatronic I want to make this work in the future. But anyway, this video is kind of getting long. We're going to pick up next time with the assembly piece and hopefully completing a lot of this script that we're working on. Anyway, I will see you all next time. So long and goodbye.